Yeah, hi, good afternoon, Sai. Maybe we'll just wait for 2 or 3 minutes and we'll get started. Uh, which textbook is preferred for probability and statistics, covering more examples and problems? I think there's a book by Sheldon Ross. I don't remember the name of the book, but mm, the authors are Sheldon and Ross, and I think that is a pretty good book, decent book for this course that you can refer to. I mean, there are others as well, but yeah, I don't recall them very particularly. Maybe in the next class or sometime I will give you a detailed list, a very comprehensive list. Okay, so the name Sheldon and Ross. I don't remember the exact name. Maybe you can just search Sheldon and Ross and then probability book, and it will come automatically, perhaps. It's a pretty yeah, popular book, so I don't think there will be. Yeah, so the recording, I'm recording everything through OBS Studio because the internet connection at my end is a bit dicey, so it's possible that, yeah, I mean, I am saying something and it doesn't get recorded, so pretty safe to keep it offline. Yeah. Okay, so just 1 minute and we'll start sharp at 3:05. Okay, maybe I should also join through my tab, right? Okay, share screen. Okay, so I hope that the tab is visible. Last time, sorry for the inconvenience caused last time. There were a lot of hiccups, and the internet connection was not so good. And I saw afterwards in the chat that many people were not able to see the screen and all those things. But the recording was pretty decent, so you can refer to the recording. Okay. All right. So yeah, I think we can get started. Okay. Uh, okay. So let me switch my OBS to iPad recording. Yeah. Okay, so hello, namaste, and welcome everyone. Welcome to this tutorial lecture. Uh, this time, so we will be covering problems related to week 5. Particularly, week 5 will basically deal with one distribution, and which is, perhaps one of the most important distributions that people, you know, keep working with all the time, which is the Gaussian distribution, also called as, yeah, normal distribution, right? So uh, so yeah, this will so today we will basically solve. So the entire week 5 was on this particular distribution. So what is the form of this distribution? So we call a random variable x is distributed normally with mean mu and variance sigma square if the the PDF fx of x is given by 1 by root 2 pi sigma uh, e raised to minus x minus mu whole square by 2 sigma square. So this is the PDF that we will be working with. And how does this distribution look like? Well, so famously, Gaussian distribution is also called the bell curve. I mean, so it looks something like this. So you have your axis. Okay, I mean, I don't think there's need of y-axis. You can just call this point mu, and it looks something like this. Okay, so so yeah, I mean, this is your famous bell curve. Uh, why is it so famous? Well, because mm because it is seen in nature that a lot of things are distributed normally. Uh, I mean, if you guys know something called law of large numbers, law of large numbers, or something called, I mean, or I shouldn't say or, and central limit theorem. These two theorems talk about why Gaussian distribution or normal distribution are so important. A lot of things in nature, in real life, are distributed normally, and uh, you can also say that, I mean, according to me, Gaussian distribution is very widely used because of its, special properties. Basically, you take a normal distribution, or you take any random variable which is Gaussian distributed, which is normally distributed. You do any affine transformation, that the new random variable that you get is still Gaussian. There are very good, nice properties of Gaussian distribution, and more than that, you know, Gaussian distributions are nice to work with both analytically as well as computationally. So, I mean, if you are running some program which deals with Gaussian distribution and you have to take inverses and things like that, Gaussian distribution is also helpful there, right? Uh, yeah, I mean, maybe something to just keep at the back of your mind. I won't state anything particular here, but yeah, a lot of it's. I think it's more about you know what do you call it? It's more about efficiency than natural things. I mean, people use it because it's very easy to work with, not because it's very natural to work with. Okay. Yeah, I mean, yeah, some philosophy there, but okay. So, I mean, so let's solve some problems. Again, if you have, after every problem, I will come back to the Teams page and see if there are any questions. Otherwise, if you have some very pressing questions that you can't hold and you just want to ask right away, just please just go ahead and ask it. Okay. Uh, okay, so maybe I'll get started. So here's the first question. Question one. So this is not related to uh, Gaussian random variables, but CDFs in general. Nonetheless, I will just go ahead and solve this one. So the problem is, so you have a random variable u, which is uniformly distributed. So it is uniformly distributed between 0 and 1. Okay. And f, this is some absolutely continuous CDF. Okay. So you have a random variable u which is uniformly distributed between 0 and 1. So the PDF or the distribution function, the the density function of u looks something like this, right? Uh, yeah, and this value is basically 1. So, and f is a absolutely continuous random variable. Okay. Uh, the question is, and the basically the the random variable corresponding to this this absolutely continuous CDF is x. Okay, so you have two random variables. The first one is u, which is uniformly distributed, and the second one is x, whose the CDF is given by f. Okay, and since f is a CDF, you also know that it's absolutely continuous. Okay, the question is, let us say you make another random variable y, which is equal to f of capital X. Okay, so f is a CDF, but it is also a function. Okay, so you can take any random variable and make a like apply a function on top of it. You will get a new random variable. So we are calling that random variable as y. So the question is, what is the distribution function of? Question is, what is the distri distribution function of y? So let me know if the question is not clear, because actually this is somewhat of an important question in the sense that, yeah, I will tell you at the end of it why it is important. But yeah, you have two random variables, u and x. U is uniformly distributed, x is distributed according to the CDF f, capital F. Now you take f, which is end of the day it is a function. You apply that function on x, which is a random variable. So a function of a random variable under certain conditions is also a random variable. You call that random variable y. Question is, what is the distribution of this new random variable y? So okay, so let's solve it. So so whenever you have to think about the distribution of a random variable, go to the basics. Okay, the basic is that you need to think about the CDF. Okay, so let's consider a small x between 0 and 1. Okay, let's call the CDF of y to be g. Okay, so let's say g of x by definition. Okay, this should be equal to what? Probability of y less than or equal to small x, right? Now this probability, now y you know is capital F of x, so this is equal to probability f of capital X is less than or equal to small x. So I'm just going by the definitions that are given to us, right? Now since f is absolutely continuous and it is a CDF, the inverse of f exists. Okay, so this should be equal to probability of capital X less than or equal to f inverse of x. So again, a word of caution: you cannot always do this step. Okay, uh, I have used the property of f that it is a CDF. So if it is a CDF, it is monotonous, right? So it is something like this. Okay, you can take the inverse of a function only if it is monotonous. If it is not monotonous, you cannot take the inverse. So just a word of caution here. Okay, maybe I'll just write it somewhere. Uh, since f is a CD. Okay, and so okay, now you have this thing. So what is this thing? This thing is actually, you can think of this as in terms of CDF of x, right? This is the probability that capital X. Now x is a different, so it was our original random variable whose distribution function was f, right? What is the probability that this capital X is less than or equal to f inverse of x, which is, you can think of this as some other x dash, right? So I mean, you can think of this as probability of x less than or equal to some x dash. So this thing you can write it as f of x dash, right? This is by the definition of capital F, which is the CDF of capital X, right? Now what was x dash? X dash was f inverse of x. So this is f of f inverse of x, right? And this, since you are, so this is the inverse and this is the function itself, so f of f inverse is just identity, right? So this will become just x. So you see g of x is actually x. So, so what does that mean? So G was, remember, it was the CDF of Y, right? So how does the CDF look like? The CDF looks like it is till 0, it's 0, okay? Because I mean, support is this the, is between 0 and 1, right? After 1, so from 0 it starts and it behaves like this function y equal to x, right? So it behaves like this, y equal to x, and that then at 1 it becomes 1, okay? So this is how this CDF looks like. Now, which distrib which PDF or which what is the density of this random variable? Uh, I mean, if you so it is pretty standard. The uniform random variable itself has this distribution, right? So it is between 0 and 1. Uh, till 0, it's 0. Between 0 and 1, it is 1, and at from 1 after it's again 0. So so actually, so you can see, right, this thing is corresponding to this distribution. So so basically, you can say that y is also uniformly distributed between 0 and 1. So yeah, uh, so this is the answer. Uh, Again, why is this result somewhat important? Is that, well, so this is one way to sample from any distribution. So let's say you are given any arbitrary distribution, okay, and you are asked to sample from that distribution. So f could be anything here, right? F is a arbitrary distribution. If you want to sample from it, instead of sampling from x, you can actually sample from f of x, which is your uniform random variable. So just sample a uniform random variable, okay, and apply this transformation f inverse to it, and that sample will come from your desired distribution, which is capital F of x. So I mean, maybe it will come later on in the course, but it is a quite an important question or result to just remember that when you apply a CDF of a function to the random variable itself, it gives you a uniform random variable, and uniform random variable is actually easy to sample from, and you can exploit this to actually sample from whatever your desired distribution is. So yeah, I mean, question wise, there's nothing difficult in it. I mean, you can do this calculation very easily. Okay, but the significance of this result is actually very profound. So yeah, just a note on that. Uh, okay, so if you have any question, you can let me know. Otherwise, I will just proceed. Okay. Okay, so let's look at another question. This one is pretty straightforward, pretty easy. So let's say x is a random variable which is again distributed normally with mean 0 and variance 4. Okay. So again, so how will the PDF of this function, this random variable look like? It is at 0 and it is distributed around 0. It has a spread of something sigma square which is equal to 4. Okay. This is given to us. And the question is, you create a new random variable from it, which is y equal to a times capital X plus b, where a is greater than or equal, so greater than 0, b is greater than b is also greater than 0, and a comma b are both real numbers. Okay. So the question is, now, well, what is the distribution of y? So okay, yeah, I mean, y is distributed according to what? This is the question. So yeah, I mean, if you guys know the property of random normal distribution is that, what is the property? Any affine affine transformation of uh, Gaussian random variable is also Gaussian. So if x is Gaussian, ax plus b will also be Gaussian or normal. Okay. However, that is not enough because a Gaussian random variable is completely specified by its mean mu and its variance, which is sigma square. So you still need to find the mean and variance of this new random variable. So one way to do it is you use your transformation of random variables and those formulas in which includes Jacobian and all those things. Another sort of easier way is to just use your basic properties of expectation. Okay, so let's call mu to be expected value of y. Okay, now y, what is y? Y is ax plus b, right? Now using linearity uh, of expectation, this is equal to a times expected value of x plus b, right? um, and what else? Now, yeah, so now you know what is expected value of x, right? Expected value of x is given to you, which is 0, because the mean is 0 here, right? So this will become 0, so this is just b, right? So the mean of this new random variable is just b. Okay. uh what is sigma square? Sigma square is expected value of y square minus expected value of y whole square, right? This is by the for basic definition of variance, right? Uh, what is this? This is expected value of y square. Expected value of y we just saw is what? B, right? This is equal to b, so this will be b square. What is expect? So now just writing things down. What is y? This is ax plus b whole square minus b square. This will become expected value of a square x square plus b square plus 2axb minus b square, right? Uh, Again, using properties of expectation, linearity of expectation, this will become b square plus a square times expected value of x square plus 2ab times expected value of x minus b square. So b square gets cancelled. What is expected value of x square? Now, expected value of x square we can calculate, right? What will it be? Expected value of, so we are given that the sigma square, which is 4, which is equal to expected value of x square minus expected value of x whole square, right? This is equal to 0 since expected value of x is equal to 0. So this means that expected value of x square is equal to 4, right? We can use this result here. So this will become a square times 4 plus, again, expected value of x is equal to 0, right? So this is equal to 0, so this term itself will go to 0 plus 0. So this is 4a square. Okay, so this is your sigma square. This means your uh, sigma is just equal to what? 2a, right? So or to be more accurate, it will be 2 times mod a, because a can be positive or negative, but yeah, I mean, okay, it's just, you can just write it as 2a, no issues. So now why? So now what about y? So like you calculated the mean to be b, and you calculated the variance to be 4a square. So, and you know that it is a Gaussian random variable. So y is distributed according to normal distribution with mean b and variance to be 4a square. So this is your like, final answer. Uh, yeah. I mean, pretty easy, but yeah, I mean, I just went a little bit in depth, just to make sure that everything is understood clearly. Okay. So, I mean, if you have any question, you can just stop me. Okay. Otherwise, I will just I answered 2A and 2 mod A is present. Which one is preferable? Okay. So yeah, so I mean, if to be mathematically correct, 2 mod A is the correct answer. Okay. I mean, it's more preferable because why am I saying this? Because sigma cannot be negative, right? It's the variance. The spread of a distribution is sigma, and the spread cannot be negative. It has to be positive. So in case if A is negative, just adding this mod will make sure that it's always positive. Okay. Uh, okay. So let's move on to another question. Uh, okay. So okay. So now let's yeah. Okay. So, so, so now we will solve some problems which will use the properties of standard normal distribution. Okay. So what is a standard normal distribution? So standard normal distribution. So we say that X is standard normal if it is normal with mean 0 and variance 1. That's it. So, so this distribution is called standard normal distribution, and uh, we have a special sort of you know what do you call it? We have some sort of special what should I call it? So we denote the CDF of this random variable x with phi. Okay, so phi of x is nothing but probability that x is less than or equal to small x. So you can think of this. So the way I prefer to think of about this function phi is that you have this Gaussian random variable. Okay, at any point x. Okay, let's say this is your x. At any point x, the area under this entire curve, which is less than x, this area, this is denoted by phi of x. Okay, so this is the way I visualize this function phi. Okay, so there was another question. If a is not equal to 0, so at what is correct? 2a or 2 mod a? Still 2 mod a will be more correct. So I mean preferable answer is 2 mod a always. Okay, so yeah, coming back to, so actually you can just speak up because I am not looking at the team space as of now. So I mean, if you post something, I most probably won't be able to see it. So yeah, maybe if you are comfortable, you can just speak up. Okay. Okay, so this is your standard normal distribution. The way to visualize it is what is the area of under this bell curve on the left of this given x. That is denoted by this function capital phi of x. Okay, so here is the question. Okay, now coming to the question. So x is a standard normal random variable, and you define this thing box x. What is box x? Box x is equal to 1 if uh, x is between 1 and 2, and it is equal to minus 1 if x is less than 0 and greater than or equal to minus 1. So it is like this function where, okay, so let's say this is your 0, this is your 1, this is your 2, this is your minus 1. Okay, and this box x, what, so this is your box x function. This is 1 when x is between 1 and 2. Okay, so it is 1 here, and it is minus 1 if it is between minus 1 and 0. Okay, So this is equal to 1, this is equal to 1. Maybe I'll zoom it to just to make sure that you see what it is. So this is your box function, and the question that is asked to you is what is the probability of x greater than 0 given that mod of box x is equal to 1. This is the question. Now, yeah, I mean, this question can look intimidating at like the first sight, but it's actually quite easy. Uh, so whenever you are asked about this kind of probability questions, whenever you see conditional probability, especially in this course, what you can do is you can just rely on the Bayes rule, which is probability of A given B is probability of A comma B. So what is A is here 0, mod of box x equal to 1 divided by probability of this conditioning event, right? Which is probability of mod of box x equal to 1. Okay, so you can always rely on this formula. And now what you have to do is you just have to sort of calculate each of these probabilities and just substitute it here. Okay, so let's start with the denominator. What is the probability of mod of box x to be equal to 1? So when is mod of box x equal to 1? So you can see it's 1 if x is between 1 and 2. It's minus 1 when it is between minus 1 and 0. However, if you take the mod, it is 1, it will be 1 here and here as well, right? Because mod of minus 1 is also 1. So, I mean, so this thing, I will just write it down perhaps. This is equal to probability of x between 1 and 2, right? Plus probability of this thing. So whenever mod x, so box x is equal to 1 or minus 1, mod of box x will be equal to 1. So we just need to add those two probabilities because it is happening only in these two cases, right? Now what is, so now, okay, now here is when we will use this CDF function phi. So, so now remember that, okay, uh, maybe I will just ask it. So do you know that this will be equal, so this thing will be equal to phi of 2 minus phi of 1. Do you know this or do I need to explain it? Maybe you can just write it in the chat or something. Because I mean, if I go on explaining it, it will take some time, but it's quite easy. Maybe you might already know it. If you already know it, I won't spend time, yeah, elaborating on it. Uh, okay, you know it. Thanks. So, so it's basically just subtracting the probability. So I mean, so it's like this. So I mean, maybe I'll just give you a brief explanation. So this is your Gaussian random variable. So let's say this is x1. Okay, phi of x1 captures everything which is less than x1, right? And let's say there is another number which is x2 here. Okay, so x2, phi of x2 will capture everything which is still here. And let's say you are asked the probability which is between x1 and x2, which is this thing, right? So so to calculate the area of this black region, you need to subtract the area of this blue thing from the area of this green thing, right? So that is basically equivalent to doing phi of x1 minus phi of x2. So yeah, I mean, thanks for letting me know that you know. Okay. So this is what the first thing will be equal to, right? Plus this second thing, what will that be equal to? Phi of 0 minus phi of minus 1, right? Okay. Now, when I see this, I will be very happy. Why? Because I can see phi of 1 and phi of minus 1 here. Now, because the Gaussian distribution is symmetric, okay, let me write it down. This is equal to phi of 2 plus phi of 0. Okay, let me keep these things separately. Uh, I will take minus outside. This is phi of 1 plus phi of minus 1. Now, whenever you see like x and minus x in the same equation with these phi, you should be very happy uh, because you know you can do stuff now without calculating things. Okay, what do I mean by that? Because of symmetry, uh, maybe I will explain it here again. So you have this distribution. Oh, this is your 1, okay, and this is your minus 1. Phi of minus 1 is this area, right, which is this thing. And so this is actually equal to the area which is this area, right, which is on the right of 1 because of symmetry. I hope you can see this, that whatever this blue area is, this blue area and this black area, both of them are same because of the symmetry of this normal bell-shaped curve. So the question is, can we write phi of minus 1 in terms of phi of 1? So what is this area now? Do we know what this area is? Actually, we do, because we know that area under this entire curve is equal to 1. Okay. And what is the area which is on the left side of 1? That is equal to phi of 1, right? This is again, maybe I will repeat myself. The area under this whole curve, I will use maybe this marker. The area which is under this entire curve, this is equal to 1. And if I subtract this area from it, from the left side area, I will get whatever there is, it is in this tail, right? This black region that I have plotted. So, and that black, this area is equal to this blue area. So actually I can write this to be equal to 1 minus phi of 1. And hence I can see that phi of minus 1 plus phi of 1 is equal to 1. Okay. And this is what I will use it in this equation in my calculation, right? This is equal to phi of 2 plus phi of 0 minus, what will this, we just saw that phi of minus 1 plus phi of 1, this is equal to 1, right? So minus 1. Now again, do I know what is phi of 0? Well, maybe I'll explain it in the same figure. This is your 0, right? This is your 0. And what is phi of 0? Phi of 0 is basically this area. Maybe I will use another color. This area, right? So, I mean, again, by using symmetry of this curve, we know that this area is equal to this, the right side area, right? Which is, let's say maybe this area. Both the areas are equal. So you are at the center, whatever is on the left is on the right. And another thing that you know is the sum of these two will be equal to 1. So what should be the value of this, just one side of it? It will be just half, right? Phi of 0 will be just equal to half. I mean, let me know if something is not clear, okay? I am just going by my pace because I don't know how much you know or you don't know. So if I am maybe rushing it, just stop me, okay? And this will be equal to phi of 2 minus 1 by 2, okay? So yeah, so this was the first half of the calculation where we calculated the denominator, okay? Now the second half of the calculation is basically calculating probability of x equal greater than 0, comma, mod of box x equal to 1. What is this? Uh, well, w- uh, so mod of box x is equal to 1 in two cases, right? When x is between 1 and 2 and x is between minus 1 and 0. And along with that, if I want to ensure that x is greater than 0, that can happen only if x is between 1 and 2, right? Because if x is between minus 1 and 0, then x is actually less than 0. That case cannot be counted. So the only case that can be counted is x is between 1 and 2. So this will simply be equal to what? Probability of uh, uh, this thing, x between 1 and 2. 1 less than equal to x less than 2, right? And again, by using the CDF, this is what? This is phi of 2 minus phi of 1, right? This is the like perhaps the simplest thing. Now, by again, I will maybe just copy this thing, uh, just avoid some writing, right? So this was our, uh, this is where we started. So we have calculated the numerator. So the numerator is equal to what? Phi of 2 minus phi of 1 divided by the denominator is phi of 2 minus half, 2 minus 1 by 2. So yeah, this is your final answer. Okay. Uh, yeah. So yeah, I mean, I don't know if it was clear or not. If something is not clear, you can, yeah, I mean, I'm here for on the chat. I will just bring some water. Let me know if something is not clear. Because next, a lot of question will be based on the similar kind of logic where we will sort of use this phi function to do stuff. Okay. Hmm. Okay, so I see no questions, so maybe I'll just proceed. Okay. Okay. So, uh, okay, which question should I take next? Yeah, so maybe we'll take this question. This one will be fourth question, right? Okay. So, here is a question. So, let's say that you have a laptop and the la each laptop has a battery. Okay. So, let's say that it is known that the lifetime of that battery, or maybe not the lifetime, the recharge time of that battery is known to be, normally distributed. So, I mean, yeah, so maybe, so you have, let's say, a lot of laptops, and you put each laptop to charge at the same time. The amount of time that it will take to get fully charged is a random variable because it will be different for different laptops, right? You did a survey and you came up to this conclusion that this random variable x, let's denote it by x, it is actually normally distributed, okay, with mean 260 minutes and a standard deviation of 50 minutes, okay. So yeah, this is your mean and this is your sigma square. The question is what is the third quartile of battery life? This is the question. So I hope the question is clear. Uh, again, what is it? So to answer this, we need to know what do we mean by third quartile, right? So third quartile, let's denote. So let's say that the third quartile is equal to Q3. Okay, Q3. Then what do we mean by this thing? Well, Q3 basically means Q3 is a number. Okay, it's a value such that probability of X less than or equal to Q3, this is equal to 0.75. So you can think of third quartile as that number which under which 75% of the population lies. Okay, so I mean you must have listened to this thing like 99 percentile, 98 percentile, something like that. What does it mean? It's so basically, let's say 99 percentile means that it's a number. So let's say there's a entrance exam, okay, and you someone says that, oh, 120 mark is actually the 99 percentile. What does it mean? It means that the number the so 99% of the students have scored below 120 is what it means. So in this case, Q3 or third quartile means 75% of the laptops get charged under Q3 minutes. Okay. Uh, I don't know if it was clear or not. Let me know if it was not clear. Okay. So this is what is being asked. So what is the value of Q3? This is being asked. And another thing is given to us that we can use okay, I mean we are already given normal, so okay, I mean okay, yeah, nothing, no assumptions are required. So how do we go about this? So okay, whenever we are asked something like this, we need to do one simple thing. What is it? Just go to standard normal distribution. So this is a normal distribution, but this is not standard normal distribution, because standard normal distribution is normal 0 1, right? We need to convert this to this. And what is the standard way to convert any normal distribution to standard normal distribution? It's simply scaling and renormalizing. Okay. What does it mean? So maybe I'll just write it down. This implies that probability of x, okay, x minus mu by sigma is less than equal to q, okay, q3 minus mu by sigma, this is equal to 0.75. So since this is an inequality, I can just, add and subtract under the rules. Okay. So I have just done that. And what is the value of mu here? X minus mu. So x minus mu. What is the value of mu? We just saw it is given to us, right? It's 260. So it's 260 and sigma is given to us to be 50. This is less than equal to Q3 minus 260 by 50. Okay. So equal to 0.75. Now, whenever you do this normalization, this new random variable is actually distributed according to normal 0 1, which is standard normal distribution. So basically, if x is distributed as normal mu comma sigma square, x minus mu by sigma, just sigma, not sigma square, sigma, this will be distributed according to normal 0 1. Okay, so we have just done that. So I can write this equation as probability of z. Okay, z is standard normal random variable, that to be less than q3 minus 260 by 50. This is equal to 0.75. Now here we need to, so okay, now here so what is the purpose of coming till here? Why do we want to convert everything in terms of this thing? Because now this thing is equal to what? This is equal to phi of q3 minus 260 by 50, right? Because this is the CDF of z, right? This is the what is the, so we are asking what is the probability that a standard normal random variable is less than this particular value. This is nothing but the CDF of this thing, right? Q3 minus 260 by 50, that is equal to 0.75. Now what you can do is you can use, so so there's a chart of the values of phi that you can use now. Yeah, I mean maybe I should have mentioned it earlier, but yeah, so this is like the, you can use the chart for phi and you can find out what is the value of this thing x, let's call it like maybe not x, maybe call it q. What is the value of q for which the value of phi is equal to 0.75? And if you look at the table, it's actually the value is so q3 minus 260 by 50, this should be equal to 0.67449. So I am just writing it from whatever is given to me. Okay. And then you can solve for Q3 and it comes out to be something like 293.72. So what I will maybe just mention is use use chart for phi, okay, to get this. And then it's simple. Yeah, in exam chart is given, okay. So you have posted some question, is it? Sai, uh, okay. What is the question? Suppose x is a random variable having the following probability distribution. Fx of x is x power L minus 1 into 1 minus x power m minus 1 by b of L comma m. The probability density function of y equal to x. Uh, I cannot understand what is this thing x power then again power. Can you speak maybe? X power. Okay, let me write it down. uh, so fx of x is equal to x raised to L minus 1. Okay, 1 minus x is here. Okay, 1 minus x raised to m minus 1, is it, divided by b of L comma m, is it? Yes, and x is less than 1. Okay, just a second. Okay, sorry. So what is this b of L comma m? I'm not sure. So is this a function? What is this function? Can you tell me? Like, what is b of L comma m equal to? Uh, uh, it looks something like beta distribution, but maybe I'll ask you to, just confirm it once. Can you get back to me after confirming what it is? Okay, so assignment 5 is not yet graded, right? Is it graded? Yeah, 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 yeah. Is it graded? I mean, is it due or is it already? Like, I cannot solve the problem that is given to you in assignment right now. I think this, I think this is your beta distribution, which is gamma of uh, gamma of L plus M by. gamma of L times gamma of N. Maybe. Just let me, maybe I will share this thing, beta distribution. You can search on Google. I will just share the link to it. Just a second. Uh, yeah, I think it's this only. Just have a look at this. This will help you. I cannot directly tell you the answer, but it's actually a pretty standard question. So there's a known fact that if x is beta distribution, well, what is the distribution of x over 1 minus x? Uh, I have sent you a link. This is a Wikipedia link for simple beta distribution. You can use this actually. Yeah, I think it's exactly what you are asking. Is that fine? Okay, cool. So I hope this question was clear, right? The previous question was clear. Uh, okay, maybe I'll solve one or two more questions. So let's say that the question 5. Uh, let's say that Z is again a standard normal distribution, standard normal random variable. Okay, so it's normal 0, 1, and Y is another random variable which is equal to max of Z comma 0. Then the question is that like there are four options that are given to you. Like Y is a discrete random variable, B is it a continuous random variable, C not a random variable, and D is it a mixed random variable. This is the question. Uh, so which one amongst these is the correct option? Uh, so yeah, we can, it's pretty straight for not pretty straight. So it's just a tricky thing. I mean, yeah, I mean, at looking at it, it looks like okay, something is fishy, but actually, you just need to remember one thing. So y is equal to max of z comma 0, right? Now max function can be written in another form. So maybe I will just write it down. So this can be written as half of z plus 0 plus mod of z minus 0. Okay, so what the property that I am using here is max of a comma b is equal to half a plus b plus mod of a minus b. I'm using this thing here, and I mean you can verify basically if this is correct or not. So this will just become what, z plus mod z by 2. So I mean you can verify. Let's say if z is equal to minus 1, what is the value of this thing? The answer should come out to be 0, right? What is this thing? So this will become 1 minus 1 plus 1 by 2, which is equal to 0. So let's say z is equal to 2. The answer should be 2, right? What does this thing do? 2 plus uh, mod of 2 is again 2 by 2, which is equal to 2. So you can see that this is actually a, I mean you can verify basically by just putting some values. So basically, if z is a standard normal random variable, y is equal to z plus mod z by 2. Now this function doesn't have any discontinuity, right? Because it's defined everywhere, and I mean just by look at it, you can see that it's not discontinuous at any point of this thing. So I mean, okay, there are no discontinuities, right? That is what it means. So, but it is a, you can say that this is a random variable. Okay, so there was one option which says that it is not a random variable. So this option is wrong. Next is Is it a discrete random variable, or is it a continuous random variable, or what is it? Okay, so we can write y to be equal to what? It is 0 if z is less than 0, and if it is z otherwise, right? This is this the definition of this thing. So what is probability of y to be equal to 0? This is equal to probability of z to be less than 0, right? Which is equal to half. This is just by symmetry, right? Probability of z less than 0 is equal to probability of z greater than 0, and the sum of these two is equal to 1, so one of them has to be half. Okay, now what is, so this was this thing, this case. Now what is the probability that y is equal to z, right? This is equal to simply probability of z greater than 0, right? Which is equal to what? Which is equal to half again, right? So so basically probability of y equal to 0 is equal to half. uh, okay, just a second. Okay, yeah, so in, if a random variable is a continuous random variable, so for any continuous random variable, probability of x equal to small x, this is equal to 0 always, right? I mean, because at that particular time the length of x, the Lebesgue measure, is 0, so this is always equal to 0. So since the probability of y at a particular point, that is 0, is equal to half, this implies that y is not continuous. This we can say for sure. Okay, and another thing is probability of y equal to z is equal to half, right? This shows that, y can actually take, uh, it's actually defined on the entire right side of your x-axis, so it's not discrete either. This implies that y is not discrete either. So if it's not discrete, neither is it continuous, this means that, y is a mixed random variable. So I mean, amongst all these two are also incorrect, and this is the correct. Let me know if there is any doubt. Uh, you have posted another question, is it? The parameter p in the quadratic is normally distributed with mean 0.2 and standard deviation 1. The probability that the roots of the quadratic equation are real is. Okay, so interesting question actually. So is this again a question of your assignment? Uh, Sai, can you just type or say something, because S and no, no is, are you saying no? Okay. So this is your quadratic equation, minus 2px plus 1 equal to 0. Okay. And p is said to be normally distributed with mean 0.2 and standard deviation of 1. Okay. So first of all, you just need to know, uh, so for the roots to be real, what do you need? You need to have your b square minus 4ac to be greater than 0, if I'm not wrong, right? Greater than or equal to 0. If that is the case, what is b square minus 4ac? That is 4p square minus 4, right? This is what it is. Greater than or equal to 0. And this means that p square has to be greater than equal to 4. This means p has to be between 2 and between minus 2 and 2. So basically the question is, if p as a this 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 random variable, okay, what is the probability that p is between minus 2 and 2? That is the question, okay. So this is like a disguised uh, a way to ask this question, okay. So what is the probability that minus 2 p 2? This is what is asked. And again, whenever you are asked this thing, just normalize everything, okay. This is equal to probability of minus 2 minus 0 minus 0.2 by 1, then equal to p minus 0.2 by 1, then equal to 2 minus 0.2 by 1, okay. And this is equal to probability of minus 2.2 z, this is 0 point, so this is 1 point. Okay, okay, so this is okay, so p square greater than, okay, okay, so this is 1 minus this thing, sorry, I'm really sorry. So this is p greater than, so, okay, so this is basically p square greater than equal to 4, and this is equal to p not belonging to minus 2 comma 2, right? Sorry, thanks for correcting me. This is 1 minus this thing, 1 minus this thing, okay. So this will just become 1 minus the complement, right? And this thing is basically, what is this thing? This is 1 minus, probability of this thing is what, phi of 1.8 minus phi of 2.2. This is one. Okay, 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 okay. Okay, yeah, yeah, yeah. Sorry, sorry. Yeah, this thing will become, yeah, yeah, yeah. You are right. So sorry. So yeah, sorry. This will become one, one. Everything will become just one. Uh, Maybe I will just do this thing again. Okay. So this thing will change. This thing will change. This entire thing will change. This is minus one. This is one. This is equal to one minus probability of 1 minus 1.2. This will become z, this will become 0.8, right? And this is 1 minus phi of 0.8 minus phi of minus 1.2, right? Yeah, so now I think you can just use your chart and just calculate this. So this is 1 plus phi of 1 minus 1.2 minus phi of 0.8. You can just calculate this thing. Is it clear? So yeah, I think I did one calculation mistake there, but apart from that, is that clear? Okay. Okay, so this was okay. Maybe I will take just last question, okay, and after that we will stop, unless you have another any other question. So this is another question. Uh, so it is given that IQ level, so you have a group of students, okay, and the IQ level of the students is actually normally distributed. So let's call that random variable the IQ of a student, which is a random variable which is denoted by X, to be normally distributed according to with mean, normally distributed with mean 110 and standard deviation of 10, okay. And you randomly select some students, okay. uh, the the question, the it is given to you that probability that the IQ of a randomly selected student X is greater than 110 plus k is equal to 0.05, this is given to you, then what is the value of k? This is the question. So you have to find the, so you are given this random variable and you are given this thing. You are asked what is the value of k. So uh, it's quite simple. What you need to do is again just go and just normalize, do everything in standard normal distribution. So you just do x minus 110 by 10 greater than 110 plus k minus 110 by 10, right? This is equal to 0.05, right? This implies probability of, this is z, right? This is z greater than 110, 110 gets cancelled, this is k by 10, this is equal to 0.05, and this thing is actually 1 minus probability of z less than equal to k by 10. This is equal to nothing but phi of k by, sorry, so this is 0.05. This implies that 1 minus, so this thing is nothing but CDF at k by 10, right? This is equal to 0.05. This implies that phi of k by 10 is equal to 1 minus 0.05. This is equal to 0.95, right? And now you can use your chart basically, and you can find that the value of k by 10 should be equal to 1.64. Hence the value of k is equal to 16.4. Right. So yeah, this was the last question from my side. Let me know if there is some doubt that you have or something like that. Is there any question? Otherwise, we can stop. So if there is no other question, then I will just stop sharing the screen. Okay. Thanks for joining. Uh, Thanks for joining the lecture. See you next week. Have a uh, have a nice day. Okay. I will. Okay. So yeah, I think there was some question, but the guy left. Okay. So we will just stop the question. Okay. Thank you.